Hi, we're going to take a look at the answers to exercise 1.1 of Unit 2, and this exercise is focused on recurrence relations. And in this particular exercise we have to work out the subsequent terms of a recurrence relation given the first term. Now in this first problem here we can see that un plus 1 is equal to un plus 5. If we replace that with the second term, u2, we find that u2 is equal to u1 plus 5. This of course is un plus 1. u2 is 1 plus 1. So we have the value of u1 is equal to 0 and we have u2 is equal to 0 plus 5 giving 5. Moving on to the next term, we can see u3 is equal to u2 plus 5. We already know the value of u2 is 5, so it just becomes 5 plus 5 is equal to 10. u3 can then be plugged into the next equation and we have u4 is equal to 10 plus 5, which gives 15. The second problem has un plus 1 equal to un divided by 10. So that translates into u2 is equal to u1 divided by 10. And u1 we're told is 100, and 100 divided by 10 gives us a value of 10. We can then take that value, put it into the next equation, u3 equals u2 divided by 10, and 10 divided by 10 gives 1. u4 will then equal u3 divided by 10, and u3 we now know is 1. So 1 divided by 10 gives 0.1. The third problem has un plus 1 equal to 2 times un. And we can put that down as u2 equals 2 times u1. u2 will then equal 2 times a half because we're told that u1 has a value of half. 2 times a half gives us 1. u3 will equal 2 times u2 and that becomes 2 times 1 because we now know that u2 is 1. And that gives us a value of 2. u4 will equal 2 times u3, which gives 2 times 2 equal to 4. The fourth problem asks us to find the subsequent values in this particular recurrence relationship where un plus 1 equals minus un. u2 will then equal minus u1, and u2 will equal minus 1 because the value of u1 is just 1. u3 will then equal minus u2, u2 is equal to minus 1, so that gives us minus minus 1, which is a value of 1. u4 equals minus u3, which in this case will just be minus 1, giving a value of minus 1. This particular series will alternate between the values of minus 1 and 1 as it continues. The fifth problem has un plus 1 equal to un squared. So u2 is equal to u1 squared, which will give us u2 equal to 2 squared because u1 is 2. 2 squared is 4. u3 will equal u2 squared, and u2 squared is just going to be 4 squared, which gives us 16. u3 squared will be 16 squared, giving us a value for u4 of 256. Final problem is just slightly more difficult. Need to be a bit careful with this, and we'll look at that as we go through it. un plus 1 equals un plus n. Now we take that with the first problem. We see if we take n equal to 1, as in un, so u1 is our un plus 1 will therefore be u2, and the value of n, well, we took n as being 1, so the value of n will be 1, and the value of u1 is 0, so we just have 0 plus 1 gives us 1 as the value for u2. u3 will equal u2 plus n. We know that u2 is 1 from the previous calculation, and the n value this time is 2. So 1 plus 2 gives us 3. Finally, u4 will equal u3 plus n. u3 we now know is 3, and the n value is 3, so n has a value of 3. 3 plus 3 gives 6, and that's our final answer. Thank you for listening.